Welcome to Honors Geometry, lesson 9.6, which has to do with identifying symmetry. And there are two symmetries we'll talk about. Actually, one symmetry we have already talked about when we were in the section of reflections, and that was line symmetry. A figure will have line symmetry if a line of reflection can map a pre-image onto itself. So if you look at this figure right here, there will be a line of symmetry right there, so that if you fold this square upon itself, okay, there will be a line of symmetry here. There will also be a line of symmetry right there. I'll have to fix that a little bit. And a line of symmetry right there, such that we could fold that image upon itself. So we could fold this half over to there, we could fold this half over to there, and then on the diagonals we could fold this half over to there. Okay, how many lines of symmetry will this hexagon, this regular hexagon, have? Yeah, that's right, there'll be 6 of them. I'll try to do them quickly. 1, 2, 3, and then along these diagonals, all these will fold upon each other. And I know I'm not hitting them all exactly right because I'm in a hurry, and I don't know why I'm in a hurry. I just feel like I should be. Oh, you want me to fix them up or not? I don't know. There. This one needs to be moved just a little bit right there. That one needs to be moved. This one needs to be moved. There. Now I feel better. Okay, how many lines of symmetry will this regular octagon have? Right, 8 of them. 1, 2, 3, 4, and then along diagonals, 4 of them. So a total of 8 lines of symmetry. Okay? How about this parallelogram? How many lines of symmetry? Okay, how about right there? When I fold this over, will it hit? No. Okay, how about here? If I fold it over, no, it'll look more like, about like that when I fold it over. Yeah, it's not going to be parallelogram, a regular parallelogram, not going to have any lines of symmetry at all. Okay, how about the star? Right there. And you know what? I really think that that is the only one on this star, because it's, the way it's drawn, it's kind of squat and not quite right. Okay, how about this arrow picture? Whoops. Right there. And this triangle, there isn't going to be any lines of symmetry that if you draw it, it will make it so you can fold it upon itself. It's just not going to happen. And that leads us to the other kind of symmetry, and that would be rotational symmetry. A figure will have rotational symmetry if a rotation of 180 degrees or less about the center of a figure can map a pre-image onto itself. Okay? So looking at this square right here, can we rotate it less than 180? Oh, hey, wow. We rotate it 90 degrees. It will land upon itself. Or 180 degrees. Or 270 degrees. So it has rotational symmetry, of course. Yeah, alright. So it has rotational symmetry of 90, 180, and 270. Okay, how about this regular hexagon? It will have rotational symmetry, won't it? Oh yeah, look, right there. Right there. Okay. What is the rotational symmetry of this regular hexagon? How many degrees is this? Alright, let's count how many there are. 1, 2, 3, 4, 5, 6 times around. I wonder how many degrees that is. And this regular octagon, wow, it definitely has rotational symmetry, and it looks like it's about twice every 90 degrees. I wonder what the rotational symmetry on that regular octagon is. It would be 45, 90, 135, 180, 225, 270, and 305. Okay. Now let's go back to our parallelogram that did not have any line symmetry. It does have rotational symmetry, and it's 180 degree rotational symmetry. If it has 180 degree rotational symmetry, it's also called point symmetry. So that parallelogram has point symmetry. This arrow, no, not even close. Triangle, no. I bet the star does, right? Oh no, look how warped that is. Told you it looked a little squat for a good star. So that does not have any rotational symmetry whatsoever. Alright. This will conclude Honors Geometry, Lesson 9.6, Symmetry.